All right, so Ian Henshaw. I work for Open Data Soft. Again, what Tyler and Walt showed you, if you don't want to go to that complexity, come see me at our booth at upstairs, Open Data Soft. But I want to talk about open source, open data, smart cities, IoT programs. So who here wants to live in a dumb city? So the term is smart city. And so the first part of this is how do we define what a smart city is? So went and looked. Smart city is an urban development vision to integrate multiple information and communication technology, so that's ICT, the acronym, and Internet of Things, so the IoT acronym, solutions into a secure fashion to manage a city's assets. So we're now talking about use of data and streaming data. Cities' assets can involve things like local IS systems, schools, libraries, transportation systems, hospitals, power plants, water supply networks, waste management, law enforcement, and other community services. So that's this definition. Now, you'll recognize that in a lot of cities, a lot of those things are private organizations that are doing that, not the city itself. So the goal of building a smart city is to improve the quality of life, which is kind of the important thing. Smart cities, we talk about this, it's improving the quality of life in using informatics to improve quality of services. So the ICT allows city officials to interact directly with the community and the city infrastructure to monitor what's going on and how to enable a better quality of life. How does this work? It works through the use of sensors integrated with real-time monitoring systems. Data are collected from citizens and devices, then processed and analyzed. Kind of the things that these guys were showing over here. The information and knowledge gathered are the keys to tackling inefficiency, and this is a guy that's written some kind of important papers about smart cities. So kind of what I was saying, it's not just the city infrastructure. It's all the people that provide infrastructure into the city. So the transportation network probably does not belong to the city. Maybe it does, maybe it doesn't. Power does or does not. Water does or does not. So you have to look at these different services. So the smart cities really is combining data from public and private assets, and also is in crowdsourcing. So here's the big problem with smart cities. There's this huge data tsunami. So when you look at what Tyler was showing, the AVL data is coming in at 100,000 records per day or something like that. You've got, air sensors, traffic conditions, all this type of data, how power is being used, all these smart sensors now in the utilities, on the roads. That data is coming at a rapid rate. It's not all in the same format. It's coming on different systems. And so the problem is not just a ubiquitous wall of water coming. It's this torrent of data coming in multiple different ways. So I'm going to talk about a solution here. And this is where open comes in. So there's this philosophy of open that means that anyone can freely access, use, modify, and share for any purpose, whether it's data, whether it's software, whether it's protocols, whether it's standards. So open can be used for anything. Open source. So this is talking about software, and it's also talking about hardware. Open source model is a decentralized development model that encourages open collaboration. And kind of the packages that Walt and Tyler were showing there were a lot of open source products. Main principle of open source software is peer production. Products such as source code, blueprints, documentation freely available at public. They were talking about things being on GitHub. This is where people have these things. The open source movement in software began as a response to limitations of proprietary code. And the models used for products such as open source appropriate technologies and open source drug discovery, but many, many other things. So open source, but also open standards. So again, this data should be in some data coming for these sensors should be in some, not a proprietary format. It should come in an open format. And the different types of sensors ought to be providing, if it's say a AVL sensor, different manufacturers should be providing that data stream in the same way. Otherwise, you have to have a different system for every single vendor out there. And cities just can't, they can't deal with too many things, right? So there's a limit to the number of sensors and applications to look at those sensors that any city could look at. So kind of in the sensor world, I think the open source philosophy has got to come, because otherwise the vendors aren't really going to survive. Open data. So this is, we talked about some of the census data. Open means anyone can freely access, use, modify, and share for any purpose. Again, so open data means anyone can freely access, use, modify, share data for any purpose. And an important thing to note that open data doesn't mean it includes personal identifiable information, any security information, or any confidential information. So all the data can't be open. Anonymized data could be open, but actual individual information should not be open data. So a solution to the smart city tsunami. So apply open to the IoT data and communications protocols, adopt open source, and adopt open data. So how to make data useful? Put it all in one place. Why do we have to go to multiple systems to find data and then find somewhere we can do something with it? Let's put it all in one place. So we look at some examples. So the town of Cary, they have an open data portal, and they include weather data. And they actually do a lot of data storytelling, using that weather data to cross and analyze different things that are going on in the city. Town of Chapel Hill, they have started putting trail sensor data on their open data portal. So now it's not AVL data, but this is kind of transit information to look at how people are using the trails and that sort of thing. What types of data? Put all in one place? Well, your open data, your closed internal data. Now for the cities, they can look at the open data against the data that can't be open. IoT data, so your streaming data, and all data types. So kind of showing here, so tabular data or time series data, geospatial data, calendar data, and image data. So put it all in one place. And then make the data useful. So metadata. Metadata is data about the data. And I'm showing here, so this is a data set on the Durham Open Data Portal. Well, metadata about two of them. The first one on the left, it doesn't really have any data about the data. You don't really know what's in that data set. There's no description of it. You don't know where it comes from. You don't know who owns it. You don't know the quality of it. And on the second one, this is now crime incident data there. There's a tremendous amount of information on that. A lot of description. So when you come to that data set, if you've got a question, there's probably an answer about what that is, where it's coming from, the provenance of it, the quality of it, how it's supposed to be used. Make the data, so clean the data. So this is permit data from the city of Austin, Texas. And when you visualize that using some clustering algorithms, first thing you notice, there's 29 points in the middle of the ocean. And I bet the city of Austin does not do any permit data for anything in the ocean. So it's just confusing when you get there. So take out those points out of the data set or hide them in the data set. And what you get then when you look at this is you're zoomed in on Austin and you can see the distribution of permit data in the city a lot easier. So when you see that you have dirty data, clean it so that the internal people and external people don't have to figure out, well, why is this bad? Make it human readable. So this is some labor workforce data that the NC Commerce puts out. And so on the left, I'm sorry. I'm looking at the wrong screen here, so I'm saying the wrong thing. Normalize the data. So on the left, you see, so this is a faceting of the data. So it looks at how many things do you have of the same type in a field. And if you look at the bottom two there, you see some things where there's some uppercase and some lowercase. And so all of a sudden you're saying, well, gee, are these the same or not the same? And this generally happens when you merge data from two different data sources, that there's not a standard way of entering that data. But if you go through and now just transform it and say, okay, turn everything in this field to uppercase, then on that facet now you only have one of each item. And so that makes it a lot more useful. So now we'll go to the one I was talking about before this one. So make it human readable. So this is labor workforce data. And on the left there, you can see the first, second, third column, they're all codes. What does that mean? When I'm looking at this data set, I have to go to another file somewhere or a website and find out what does that code mean. But you see on the right, that code has been transformed into actual words. So where we had a code in the second field there, now all of a sudden we can tell what that code means. We don't really need to know as a citizen or even anybody on the job. If that's just a code, it's useless. If it's words, it's useful. So make it human readable. And then the last step here is co-creation. So open data and citizen involvement. So this is now a process called co-creation. And it makes smart cities more successful. So, because everybody wants the quality of their life to be improved. Government doesn't know what citizens want all the time. And if we put all of our heads together, we're all smarter together than we are individually. So, so that is really the process of co-creation. And with that, short presentation, but right, crowdsourcing is a way to get data in. So through an app or just the data that comes off your phone all the time. So as you're walking around, if you're on Wi-Fi, you're moving through different Wi-Fi zones in, say, a city that's providing Wi-Fi, they can actually track your movement using that, or through GPS. The phone providers track a lot of stuff, but it's not made open data because it's personal information. If they're looking at like your phone MAC address, which is the code that the networks use to identify individual objects. Right, but if you anonymize that data, and there was a good article of the London tube system, and they have these cards that at the entry and exit, they had that point, but they didn't know what route you went through the tube. So what they did is they have a Wi-Fi system in there. And so for the people with their phones turned to Wi-Fi, they were able to track individual people going through the system. So they knew what pathways people were taking. Now they actually put that data out as open data. How did they do that? They hashed the MAC address so that it became indecipherable. So now you couldn't tell who was who, right? And so now not only the system could do analysis, but individuals that are interested in doing analysis, like these guys here, Walt and Tyler, they could do some analysis and say, hey, this is kind of something interesting that's going on in the system. Maybe times of the day, parts are overloaded or something like that. And so, information can be put out, say, hey, if you want a train that's not so crowded, take a different route. And this one's just as successful, and maybe 25% of the people use that one. So if you don't want to be in the crowded train, try to take a different route. So again, quality of life. But